only two examples. Okay, so 13.7 is basically the tangent planes and normal vectors. So how we can define these two terms, that what is tangent plane and what is normal vector, that you have to assume that you have any function with the three variable. Okay, so assume that you have function f with x, y, and z, three variable function, as a continuous first order partial derivative and that has a point P naught, which is x naught, y naught, and z naught, is a point on the level surface. Okay, on the level surface. So any surface of that function f of x, y, and z that is equal to c, if the gradient we know, we discussed before, the gradient of a function at point x naught, y naught, and z naught, okay, should not equal to 0. If the gradient of a function, that function at point x naught, y naught, and z naught is not equal to 0, then we can say that n is equal to the gradient of a function at point x naught, y naught, and z naught is a normal vector. Is a normal vector. Okay, so any function's gradient, if you substitute the point, if it is not equal to 0, that will be the normal vector. Okay, normal vector to S at P naught. And what is the tangent plane? And the tangent plane to S at P naught is the plane with equation with this one, that you have to do the partial derivative of a function f of x at point x naught, y naught, and z naught, and multiply with x minus x naught. Similarly, plus partial derivative of y at point x naught, y naught, and z naught, y minus y naught, plus partial derivative of z at point x naught, y naught, and z naught, z minus z naught, equal to 0. So this equation is called the equation of a tangent plane. Okay, this is the normal vector. We can calculate a normal vector like this one. Just what we do, you have to find the gradient and put the point, and this equation is the equation of the plane, tangent plane. Now I will give you example that how we can find the normal vector and equation of a tangent plane from any surface is given to us. Okay, so see the example that example, consider the surface which is equal to x square plus 4y square plus z square is equal to 18. Find an equation of the tangent plane to the surface at point 1, 2 and 1. Okay, so for this one we need a function of 3 variables. Okay, so f of x, y and z we can calculate from this equation, which is equal to x square plus 4y square plus z square. Okay, so what is the partial derivative of f with respect to x? What is the partial derivative? That is equal to 2x. And if I substitute the point partial derivative of x at point 1, 2 and 1, that is equal to 2. Similarly, what is the partial derivative with respect to y? That is equal to 8y. And what is the partial derivative at that point? That is equal to 8 multiplied by 2, that is equal to 16. Okay, similarly partial derivative with respect to z, that is equal to 2z, and partial derivative of z at the point 1, 2 and 1, that is equal to 2. Okay, so now the gradient of a function at point 1, 2 and 1, that is equal to 2i plus 16j plus 2k. So that is a normal vector. So normal vector will become 2i plus 16j plus 2k is a normal vector. Normal vector. Now we have to calculate the equation of a tangent plane. So what is the formula? The formula for equation of a tangent plane is the partial derivative of x at point x naught, y naught and z naught, x minus x naught, plus partial derivative of y, x naught, y naught and z naught, y minus y naught, plus partial derivative of z, x naught, y naught and z naught, z minus z naught is equal to 0. Okay, so substitute the point. What is the partial derivative of x at that point? Partial derivative of x at that point, that is equal to 2. Then x minus x naught. X naught is 1. I write here 1. Plus, what is the partial derivative of f with respect to y? That is equal to 16. I write here 16. Y minus y naught is what? 2. I write here 2. Plus partial derivative with respect to z, that is 2. Z minus z naught is 1, which is equal to 0. So simplify it, you will get 2x minus 2 plus 16y minus 32 plus 2z minus 2, which is equal to 0. 2x plus 16y plus 2z minus 2 minus 32 minus 2, that will be minus 36 is equal to 0. So this is the equation of the tangent plane. Okay, is this clear? If you know the formula, you can easily find the equation of a tangent plane. So now the last example, that if the surface is given and find the tangent plane. Example, find an equation for the tangent plane to the surface z is equal to x square y at the point 2, 1 and 4. Okay, now we have to find the equation for this one. So solution, we need a function with respect to x, y and z. Okay, so this equation is given to us, z is equal to x square y. So you have to change this into the function of x, y and z, that is equal to z minus x square y. Okay, is this clear? Now you have to find the partial derivative with respect to x. What is the partial derivative with respect to x? That is minus 2xy. Substitute the point, that is 2, 1 and 4, that is equal to minus 2, 1, minus 2, 2 and 1, which is equal to minus 4. Similarly, what is the partial derivative with respect to y? That is equal to minus x square. With respect to y, the point is minus into 1 square into 2 square, that is equal to minus 4. Partial derivative with respect to z, that is equal to 1. So if you put the point, that will give you the same value, which is equal to 1. Okay, so now the gradient of the function at point 2, 1 and 4 is equal to minus 4i minus 4j plus k. So the normal vector will become minus 4i minus 4j and plus k. This is the normal vector. Now calculate the tangent plane. What is the tangent plane formula? That is f of x, x naught, y naught and z naught. I write again the formula because if you see many times you will remember that. X minus x naught plus partial derivative of y, x naught, y naught and z naught, y minus y naught plus f of z, x naught, y naught and z naught, z minus z naught, which is equal to 0. So substitute the values. Partial derivative with respect to x at that point, which is equal to minus 4, you can write minus 4. X minus x naught is what? 2 plus partial derivative of y, that is also equal to minus 4, y minus 1 plus partial derivative with respect to z, that is equal to 1, z minus 4, which is equal to 0. Simplify it, you will get minus 4x plus 8 minus 4y plus 4 and plus z minus 4 is equal to 0. You can write minus 4x minus 4y plus z. This plus and minus 4 cancel, plus 8 is equal to 0. You can also write negative sign, you can common, 4x plus 4y minus z minus 8 is equal to 0. Okay, so this is the equation of the tangent plane. Equation of the tangent plane. Okay, is this clear? So this is how you can calculate the normal vector and the equation of a tangent plane. This is the normal vector. Okay, if I ask you to find the normal vector, you have to just find the normal vector only. Okay, if I ask you to find the tangent plane, then you have to find the normal vector and the equation of a tangent plane both. So don't confuse with these two terms, normal